Hello, I'm Fritz, and today we are going to be looking at the quadratic formula. To use the quadratic formula, the equation must be in the general form: ax squared plus bx plus c equals 0, where the values of a, b, and c are constants. We now use these constants a, b, and c in the quadratic formula, and you must remember to write the equation correctly. The equation states that x equals minus b plus or minus the square root of b squared minus 4ac, all other than 2a's. Minus b plus or minus the square root of b squared minus 4ac, all on 2a's. For example, in the equation shown, a is equal to 2, b is equal to 1, and c equals minus 3. In the second example, a equals minus 1, b equals 4, and c equals minus 4. Note that the equation must be in general form for you to have the values, to read the values of a, b, and c. Let us take a first example. X squared minus 4x plus 3 equals 0. We state the values of a, b, and c. Here a is equal to 1, b equals minus 4, and c equals 3. We state the formula, which is x equals minus b plus or minus the square root of b squared minus 4ac, or that on 2a's. We now substitute the values in this formula. We have minus 4 because there is a minus in the formula and b is minus 4, so we have those two minus signs, plus or minus the square root of b squared, that's minus 4 squared, minus 4 times a times c. In multiplying, it's good to use the parentheses in the equation. All this on 2a's, a is equal to 1, so 2 times 1. We simplify the values to obtain. The two minus signs becomes a plus because there's no digit in between. So minus 4 becomes plus 4, plus or minus the square root of minus 4 squared is 16, minus 4 times 1 times 3, which is 12, all that on 2 times 1, which is 2. This gives us 4 plus or minus the square root of 4, all this on 2. And simplifying, the square root of 4 is 2, so we have 4 plus or minus 2, all that on 2. Thus, x equals 4 plus 2 on 2, and x equals 4 minus 2 on 2. Remember that the quadratic always has two roots. It can be repeated, it can be discarded. Finally, x is equal to 3 and x is equal to 1. Alright, let's take another example. We have 2x squared plus x minus 3 equals 0. We start by stating the values of a, b, and c. Here a is equal to 2, b is equal to 1, and c is equal to minus 3. We state the formula: x equals minus b plus or minus the square root of b squared minus 4ac, all that on 2a's. We substitute the values in this formula to have b is equal to 1. So we have minus b gives us minus 1 plus or minus the square root of 1 squared minus 4 times a is 2, and c is equal to minus 3, all that on 2 times 2. We simplify these values to obtain minus 1 plus or minus the square root of 1 minus 4 times 2 times minus 3 gives us plus 24, and divide all of that divided by 2 times 2, which is 4. So minus 1 plus or minus the square root of 25, all that on 4, giving us minus 1 plus or minus the square root of 25, which is actually 5. So we write 5 in its place, all that on 4. Thus, x is equal to minus 1 plus 5 on 4, and x equals minus 1 minus 5 on 4. Finally, x is equal to 1, and x is equal to minus 3 on 2. To do better, it is very important to solve many more problems. Let's take the next example. 4x squared minus 4x plus 1 equals 0. We start by stating the values of a, b, and c. Here a is equal to 4, b equals minus 4, and c equals 1. We state the formula: x equals minus b plus or minus the square root of b squared minus 4ac, all that on 2a's. We now substitute the values in this equation to have minus 4 plus or minus the square root of minus 4 all squared minus 4 times 1, all that on 2 times 4. We simplify these values: 4 plus or minus the square root of 16 minus 16, all this on 8. So that gives us 4 plus or minus the square root of 0, all that on 8. and the square root of 0 is 0, so we have 4 plus or minus 0, all that on 8, thus giving us x equals to 4 plus 0 on 8 and x equals 4 plus 0 on 8. Finally, x equals a half and x equals a half. This particular quadratic has equal roots or repeated roots. Some important remarks. In the quadratic equation x squared minus 3x equals 0, the value of c equals 0. In x squared minus 4x equals 0, b is equal to 0. This type of equation is also called the difference of two squares and has the general form ax squared minus c equals 0. In x squared plus 4 equals 0, the quad has no real solution. That's grade 11 and 12 maths. It has complex roots. In all quadratics, a can never be equal to 0. If a is equal to 0, the quadratic becomes a simple linear equation. The discriminant d. In all quadratic formulae, b squared minus 4ac is called the discriminant. Why? It helps us to tell us about the nature of roots. If the roots are real and distinct, if the roots are equal, or if the roots are complex. Let us see how to obtain the nature of roots. Let the discriminant d be equal to b squared minus 4ac. If d is greater than 0, we will have two real and distinct or unequal roots. If d is equal to 0, we will have two real roots which are equal or repeated. If d is less than 0, we have complex roots in school maths. No real roots and no solution in R. As an advice or secret to practice. Thank you so much and stay tuned for more details.